So the normal, or Gaussian distribution, is a continuous probability distribution. Now, it has a higher frequency of values around the mean and fewer occurrences away from it. Now, it is used as a first approximation to describe real-valued random variables that tend to cluster around a single mean value. It is a bell-shaped curve and is symmetrical. And the total area under the normal curve will be 1. In a normal distribution, to standardize comparisons of dispersion, a standard z variable is utilized. Now, the uses of a z value would be that it is very unique for each probability within a normal distribution, and it helps in finding probabilities of data points anywhere within the distribution. It is also dimensionless, which means there's no units like millimeters, liters, columns, anything like that. So let's talk about the formula to calculate normal distribution. So here is the formula for normal distribution. Now this is where z is equal to the number of standard deviations between y and the mean. Now y is the value of the data point that we're concerned about, while the mu symbol is the mean of the population. And all of that is divided by the standard deviation of that population. So let's calculate normal distribution. So let's suppose the time taken to resolve customer problems follows a normal distribution with the mean value of 250 hours, the standard deviation value of just 23 hours. So what is the probability that a problem resolution will take more than 300 hours? So here I have the normal distribution formula that we just previously discussed. So let's fill in some of the blanks. So we're going to say our y is going to be 300. That's the number that we're after. Now our mean is going to be 250. And then finally, our standard deviation was 23. So now we just basically fill in the blanks. So our z is going to equal what? Well, we have to first have our y, so our z is going to be equal to 300 minus our mean, which is 250. And we're going to divide that by our standard deviation of 23. So when we have all that, we can just plug that into a graphing calculator and we'll have 2.17. So from a normal distribution z table, we get the value of 2.17, which covers an area of about 98.5% under itself. Thus, the probability that a problem can be resolved in less than 300 hours is 98.5%. And the chances of a problem resolution taking more than 300 hours is 1.5%. And that's how we figure normal distribution.